Welcome to our second lecture about Object-Oriented Programming. ברוכים הבאים לשיעור השני שלנו על תכנות מונחי עצמים. This lecture will be given in English, but every now and then I'm going to provide some Hebrew translation. So, in the previous lecture, we saw some examples of objects like bank accounts, fractions, points. And in this lecture, we'll continue to talk about these objects from a new perspective. In particular, let's begin with the bank account. And as discussed in the previous lecture, we have a template, or in Hebrew, a tavnit, from which we create bank account objects. And this template is the bank account class. So we use the class constructors to create new bank accounts when we want. And every one of these bank accounts is a bundle of values. כל אחד מהאובייקטים האלה זה מין חבילה של ערכים. These values are an int, a string, and a double. And we can treat this bundle as one entity, ישות אחת, which we call object. Now, the client view of the bank account class says, how can I write code that uses and represents bank account objects? This is the view which is taken by programmers who write code that wants to use bank account objects. But there's also the developer's view, which is the person who has to write this class, who has to develop the bank account class. And that's the view that we are going to take in this lecture. So in the previous lecture, we talked about using objects. In this lecture, we'll talk about both using objects and implementing or realizing these objects. All right. Now, when you set out to build a new class, if it's an important class like bank account, let's assume that you want to build a company that will manage a digital bank. How would you do it? Well, you have to start by defining your product. And in order to do this, you begin analyzing possible banking applications. So you will think about, what kind of information you want to keep about every bank account. What kind of manipulations or operations you would want to do on bank accounts. Now, how do you do it? I mean, you are not a banker. You are a developer. You are an entrepreneur. You are a graduate of our computer science program. Well, what you do is you build a design team consisting of possible bank customers, your friends, your relatives, your mother, different people who open and use bank accounts. You take some representative customers, you take some product managers, you take some system architects, you lock them up in a room somewhere, and after 2 weeks or so, they come out with design documents, and one of these design documents will be the bank account class API. So here's the API that I designed for the purpose of this lecture. And this is the API that I'm going to give programmers who will write code that uses bank account objects. Here is an example of such code. So we see that in this client code, Alice, well, I shouldn't say Alice. We don't have people here. We have code. So we create a bank account object variable called AliceEc, and we create it by calling a bank account constructor. And then we call another constructor in order to create the Bob account object variable. And then we run some typical operations like Alice withdraws 200, Bob deposits 500, Alice transfers 400 to Bob, and so on. So basically everything we do here, we do by reading the API. You see, we have the API available to us, so we can read it and decide how exactly to write this code. That's the beauty of an API. It enables us to write client-level code without worrying at all about how this class bank account is actually implemented. Now, if you read the API, and we'll begin to read it now and give it meaning, we see that at the top it says a bank account has an ID, which is an int, an owner, which is a string, and a balance, which is a double. It's important to write it in the documentation because nowhere else in the API do I see this information. So I wrote it down. And now I want to begin to talk about how I actually implement this information. Well, I do it by creating a set of 3 class-level variables. And these variables have several different names. And it's a little bit confusing, but you have to get used to it. Some people call these variables private variables for obvious reasons. You know, it says private blah, private this, private that. But it's also customary to call these variables fields. Every object that we construct from this class will have its own set of private variables or fields. And these fields are also sometimes called properties and attributes and even class members. It depends on the language. In Java, we typically call it fields. In C#, we typically call it properties. It means exactly the same thing. And I will now say it in Hebrew. מאפיינים של כל אובייקט, לפעמים קוראים לזה משתנים פרטיים, לפעמים קוראים לזה תכונות, לפעמים קוראים לזה attributes, זה מאפיינים, וכמובן שדות. אחרי שאמרתי את זה בהתחלה, זה השם שאנחנו בדרך כלל נשתמש בו. ולכל אובייקט יש סט פרטי משלו של 3 שדות כאלה. So, if we change the balance of one bank account object, it has no impact whatsoever on any other bank account object. Each object maintains its own set of private fields. Now, going back to the API, how do I initialize these fields? How do I create objects? Well, I do it using constructors, as you know from the previous lecture. So let's take a look at the code of one of these constructors. And we begin with the signature, and a constructor is a method which is used for creating new objects. And it says so in the documentation. It also says, or you can see it from the signature, that it expects to get owner and balance data, and it is going to generate the account ID automatically, which makes perfect sense, right? You don't want the users to tell you what ID they want for their accounts. So here once again is an example of client code. Alice is creating an account, and the constructor is going to get into action and create this account. Let me backtrack for a minute, and if you look at the client code, we see that we use the word new, which in Java means create a new object, and then we call the bank account method. So the bank account code will start running. Now, what will this code do? Well, when the compiler compiles the bank account class, it will compile the constructor. And as I explained in the previous lecture, the compiler is going to inject code into the translated code, into the machine language code, that calls the operating system and tells the operating system to find a memory block which is going to represent this particular account data. And the operating system function which performs this operation, by the way, it's called alloc, not relevant for this course. Alloc returns the base address of the memory block that was just found. And then the constructor generates machine language code, which creates a variable called this. And the this variable is going to contain the address of the memory block that represents this new object. And we're going to use this variable called this a lot in this lecture and in future lectures also. And I will have a lot to say about this later on. Now, when the constructor code terminates, it returns the value of this to the caller. So when you look at the client code, you see that when the call terminates, the value of this, which is the base address of the object that was constructed, goes into the Alice account object variable, which makes perfect sense, right? We wanted to create a new object and we wanted to store the base address of this object in Alice account, and that's exactly what we got. All right, moving along, here is the code of the constructor. So it begins by calling a method called generate ID that creates a unique ID, and I will talk about this method later on. It's one of the methods of this class. And generate ID will create a unique ID, מספר חשבון ייחודי, and this ID goes into the this ID field. And then the constructor takes the values of the owner and balance parameters and puts them into the owner and balance fields of the current object, of this object, which is the object that was just constructed. And then the bank account constructor terminates and returns the value of this to the caller. This is not seen in the high-level code, but that's exactly what happens behind the scene, מאחורי הקלעים. All right, so when you write a constructor, you can call the parameters of the constructor anything you want. You know, you can call them X and Y instead of owner and balance. My recommendation is to always use the names of the fields for the names of the parameters of the constructor, and to use the reserved word this to distinguish between the parameter and the field when needed. You know, you look at the last two statements. It doesn't make sense to say owner equals owner, balance equals balance. When you say this dot balance equals balance, it means take the value of the balance parameter and put it in the field balance of this object, of the current object. All right? Okay, moving along, I see that I can also call another constructor in which I don't have to specify the balance. And indeed, we have a signature of such a constructor that promises to create an object with a zero balance. So one way to do it is to use this code, you know, plain and simple. And another way to do it is to use this code that you see here. So we can do either this or that. Now, it turns out that it's better to use the second version of this code. And let me explain what is going on here. Well, first of all, you have to realize that a class that represents objects typically has several constructors. Now, the constructors, you know, most of the code of the constructors is the same, but they differ from each other in some little details. So instead of repeating the code over and over in all the constructors, what we want to do is to have one constructor call another constructor for its effect, for its work. And we do it by using the special syntax, which is a little bit strange, this whatever. You know, when we say this, the compiler understands that you want to call another constructor that has the name of the class, like all constructors do, and you want to pass to it the parameters, in this case, owner and 0. So we are going to create an object with a 0 balance. So that's the recommended way to write more than one constructor. So back to the API, we talked about fields, we talked about constructors, and now let's move on to talk about what is known as member methods. Member methods are methods that operate on the current object. This is the object that we also refer to as this. And for example, let's start with the toString method that we discussed last time in the last lecture, but now we'll open it up. So here is the signature. The toString method provides a textual representation of the current object of this bank account. And the code is quite trivial in this case. All we do is we print the values of the fields of this particular object, of the current object. So we print or we return ID, owner, and balance. We concatenate them into one string, and this can help the client code inspect the contents of the objects that the code creates. So for example, here's a client code that creates an object variable called LSEC, and then we apply the toString method to the LSEC object variable, and we print the result. And the result is 1 LS 1000. Now, as I said before, methods operate on the current object, on the object that this pointer refers to. And here, when we go to the client code, we see the other side of this relationship. The client code calls the toString method on LSEC. By doing so, LSEC becomes the current object of the bank account class. So actually, the contents of the LSEC variable, which is a memory address, goes into the this pointer, which is used in a bank account, and that's why the code of toString actually works. Now, and I will get back to it in a minute, to this notion of this, which I realize is a little bit confusing. Let's take a look at the second print statement in the client code, and we see that here we printed LSEC and we didn't bother to say toString, and still we got the same result when you look at the output. Well, this happens because in Java, when you say print the name of a variable, if the variable is an object variable, the Java compiler assumes that you wanted to say object variable dot toString. In other words, it applies the toString method automatically to your object variable, and that's why you get the same result. And the compiler gives you this feature because programmers print objects all the time. They do it for debugging purposes, and it's quite a nuisance to remember to always put dot toString. So the compiler, gives you this nice shortcut. Now, we could have said, if we wanted, we could have said return this .id plus this .owner plus this .balance. And if we would do this, it will be more obvious that we are referring to the current object, to the object that this refers to. But notice that we didn't do it, and that's because another convention in Java, when a method code mentions a variable, like ID, like owner, the compiler checks if this variable is a parameter of the method or a local variable. If it's neither a parameter nor an object nor a local variable, the compiler assumes that we refer to a class level variable. This class level variable can be either a static variable or a field. And in the case of this class, we have only 3 fields. So the compiler understands that we refer to this.id, this.owner, and this.balance. Now in practice, we recommend not to use this unless you have to. And in this particular case, you don't have to use this. If you overuse the this reference variable, it makes your code cluttered. אם משתמשים יותר מדי ב-this, במשתנה הזה שנקרא this, זה רק יוצר בלבול בקוד. זאת אומרת, יותר קשה לקרוא את הקוד. אז אם לא צריך, לא משתמשים בו. Alright, back to the API. Let's take a look at these 3 methods, which are sometimes called getters. So we have getter methods and setter methods, and each has a different purpose. So here is the signature of getBalance, and getBalance is a regular method that operates on the current variable, on the current object, and it is designed to return the value of one of the fields of this object, in this case, balance. And these methods are typically called getters, and we write the word get, and then we write the name of the field. And here is the sister of this method called setBalance. And setBalance is also called a setter or mutator. If getBalance returns the contents of a field, setBalance is used to change the contents of a field. And that's why it's called a setter and also a mutator. Here is an example of client code that uses both of these methods. We create an object called AliceEck, and then we put in the double variable BAL, we put the contents of the balance field of AliceEck. We apply the getBalance method on the AliceEck object. And then in the next statement, we apply setBalance to the same object, and we change the balance of Alice from 1,000 to 10,000. Lucky Alice. Notice that the second call is a call to a void method. And because we are calling a void method that doesn't return a value, we don't have to assign the result to any variable. All right, so that's an example of using a getter and a setter. Now let's open the black box. In this case, I'm sorry, before we open the black box, we open the black box. Yeah, actually, what I wrote here is just a summary of what I said before. These are examples of applying methods to an object. Here is the black box, which in this case is very simple. GetBalance simply returns balance. And setBalance does this.balance equals whatever is the value of the balance parameter that was passed to me. In this example, it was 10,000. All right, so we can add more getters and more setters, one for every field or for those fields that we want to manipulate. And in general, if you ask yourself which accessor and getter methods, I'm sorry, I meant which getter and setter methods I want to specify and develop, the answer is it depends on the application. You know, it depends on which fields you want to expose to the client code, which fields you want to manage yourself inside the bank account class. It's a matter of application requirements, and it changes from one context to another. Now, let me give you an example of a bad design situation. So I created a very similar class, but just to distinguish it from the other class, I called it unsafe bank account. And here I also define 3 fields, but instead of declaring them private, I declare them as public. Now this makes a big difference. And the constructor is exactly the same as we had before, but it has a different name. It must have a different name because the name of the constructor must be the name of the class. Now, the fact that we declared these object variables as public means that every programmer in the organization can access these fields and do whatever he or she pleases. For example, here's some client code that creates a new bank account, and then the user says, let's see what is the balance of Bob, and we do it by simply writing the name of the object dot the name of the field. Because the field is public, it is exposed. Anyone can look at it. Not only look at it, you can also change it. You can give Bob $10 billion or whatever it is. You can change Bob's owner to Zorro instead of Bob. You can set the ID to -17. You can do whatever you want. And if you'll print Bob's object, you will see that it now contains all these crazy values. Now, you have to understand, if you build, for example, a digital bank company, and you're going to hire 1,000 programmers to this company, well, by now, every programmer can do whatever he or she wants to any object to any bank account in the organization, which obviously is crazy as far as security goes. So the good solution is what we do here and what we did before. We protect the fields of the objects by setting them to private. And this means that only methods within bank account can access these fields. No other class can access these fields. The only way to access the fields is to go through getters and setters. The getters and setters, as you see, are public, but I decide which getters and setters to expose. If I don't want to give access to one of the fields, I don't provide the getter and setter. And also, if I want, I can put in the getters and setters, I can put all sorts of code to verify that the client is permitted to do what he or she wants to do. So for instance, I can run a login procedure. I can send an SMS to the client's cell phone and check that he's legitimate. I can record the transaction, remember what the client did. The important thing is I have an envelope. I have a method called getID. I have a method called setID. I can put whatever code I want inside these methods in order to manage the access to the fields of my bank accounts. And so private fields, public getters, public setters that I control. So this once again is called managed access. I don't give unrestricted access. On the contrary, I manage the access, and I can do all sorts of things in order to protect the data of my objects. All right, back to the class API. Let's see what we analyzed so far. We looked at the constructors. We also looked at getters, setters, and we looked at the Tostring method. Now, what you see here is the minimum functionality that we expect to see from a class that represents objects. And I take the trouble of saying a class that represents objects because you have to realize that all the classes that we used in this course up to this point did not represent objects. All these classes were libraries of one or more functions. But these classes are quite different. They have fields, they have constructors, they represent objects. Any one of these class, I have one bank account class, but this bank account class can generate 1,000,000 different instances of bank accounts, depending on the client code. So when you develop such a class, it is expected from you to provide at least constructors so that the client code will be able to create objects, and accessors and setters, at least a few, to be able to do something to these objects and also print them using Tostring. Now, obviously, you have typically you have more functionality, which depends on the application. Excuse me. And in the case of a banking application, it will make sense to provide means to do deposits, withdrawals, transfers, and so on. So let's look at these methods as well. Well, once again, we open up the class, the bank account class. We see the fields. We have the constructors. We have some getters, setters. There's one setter that I want to look at, set balance. We talked about it before, which is used to set the balance of the current object or the this object. And now we have these three banking specific applications: deposit, withdraw, and transfer to. Here is some client code that uses these methods. So we create two accounts, Alice and Bob. Bob withdraws 200 by applying the withdraw method to Bob account. Alice deposits 1,000. Alice transfers 400 to Bob, and so on. All right, so opening up the black box, here is the code of deposit. And notice that if I want to deposit some, if I want to add some dollars or shekels to the balance of the current object, there are two ways of doing it. One of them is I can write a statement that says balance equals balance plus sum, right? Which makes perfect sense. But instead, I prefer to call the set balance setter and pass to it balance plus sum. Now let's analyze what each one of these variables means. Sum is the value of the sum parameter, and balance is the value of the balance field. Once again, the compiler knows that balance is a field because it is not defined in the deposit method. And if it's not defined in the method, it must be a class variable. So that's how I set the balance to a new balance. Let's look at the code of withdraw. It's exactly the same logic. Instead of adding some, I take away some from the balance, and I use set balance to do it. The last method is a little bit more complicated. This is a transfer. Let's start by reading the signature, the documentation. It transfers the given sum. Notice the sum is the name of a parameter. It transfers the given sum from this bank account, from the current bank account, to the other bank account. Now, every one of these words is important. It took me a while to come up with the exact description of what is going on here, and every word counts. When I say this bank account, I mean the object that this refers to, the current object. When I say the other bank account, I mean the bank account that the that the parameter other, which you see in the signature, points to. These are two different objects. If we go back to the client code, to the last statement, we see that Alice, which is one object, transfers money to Bob Eck, to Bob. So Alice will become this, the current object, and Bob will become other, the other object. So everything here is, very carefully accounted for. How will the code look like? Well, I could have done something like, accessing the fields of the object directly, but instead I do it, I think, more elegantly. Well, I didn't plan to talk about this for now. And basically I do it like this. I say other dot deposit sum and this dot withdraw sum. So basically I apply the deposit method to the other variable. So I take away sum, and I apply the withdraw method to the this variable. So I add sum to the current object. And by the way, I don't have to say this dot. If I didn't say this dot, if I just wrote withdraw, the compiler will understand by default that I'm withdrawing money from the current object. I'm applying the withdraw method to the current object, but I wrote this to make it more clear that we take money from other and we move money to this. I realize that what I'm explaining now is a little bit cryptic, קצת מסתורי, but you'll get used to it. You'll have lots of opportunities from now until the end of the course to play with objects, beginning with the workshops this week and homework 9 and 10, and you'll get used to work with the objects and to understand this crazy terminology. All right, let's move on. And and basically, here I sum up what I said before. A method is allowed to call another method. And when I say set balance, once again, it's the same as saying this dot set balance. It's as if you just say the name, if you just write the name of a method, the compiler understands that you want to apply this method to the current object, to this. And that's basically what I say in the second bullet of this note here. All right, back to the API. Let's go back to the constructor and explain something that I did not explain before. The documentation of the constructor says that when you create a new object, the account ID will be a running integer generated automatically. And the meaning here is that the first account will get an ID of 1, the second account will get an ID of 2, and so on. Well, this has to be managed somehow, and the place to manage it is inside the constructor when we create a new object. So let's see how we do it. I open up the constructor's code, and I also list the names of the fields, and we see that the constructor's code begins by calling a class method called generateID. Now, generateID is a method which is designed to create a running number ID, and here is how I implement it. I implemented it by first defining a static variable called next account ID, and I set it to 1 before before I create any object in this class. Now, what is a static variable? A static variable is a variable that belongs to the class level and it doesn't belong to any object. Very different from fields. You see, the fields are not static, and if we don't say static, we mean that every object will have a set of its own fields. And next account ID, on the other hand, is just a simple variable that exists at the class level, and any method in the class can use it. In particular, the generate ID is going to use it. And, and that's what I just explained. And let's look at the code. So we call generate ID from the constructor, and here is the method itself. So generate ID, the documentation says generates an account ID, and basically it returns the current value of next account ID, which is a class variable, and after returning this value, it advances this static variable by 1. So the next time we'll call generate ID, it will return 2, and it will advance next account ID by 1, and so on and so forth. So basically, I created a method that knows how to generate IDs, sequential IDs, automatically, so to speak. All right, and and this method, by the way, is very different from the other methods in this class, because notice that this method is static. And when I say static method, I mean that this is a method that doesn't operate on objects. It simply returns the value of a variable and advances this variable. It has nothing to do with this object or with any other object. And that's why I called it static. All the methods that we wrote in this course up until now were static. And they were static because we didn't have objects. And now you see that when you write a class that represents objects, it is possible that some of the methods of this class will be static, and these are typically what is known as helper methods. And helper methods are designed to simply help other methods do their job. And this is a very good example of a helper method that helps the constructor create unique IDs whenever we create a new bank account. All right, back to the bank account class. Let me make some general observations. You know, it's easy when you talk about all these nitty-gritty details to forget the big picture. And the big picture is quite important. It's important because if you do a good job designing a class like bank account, you're essentially building an organizational standard. So once again, you know, if you start up a company, which is a digital bank, and you're going to have many programmers working, writing code in this bank, it's very important to make sure that they all use the same terminology and the same functionality. If you give them an API that you designed, you know, if you're a senior software architect and you know what you're doing and you design a well-designed API, then all the programmers in your organization will be forced to work with this API. That's the only way to access objects, to change objects, to withdraw money, to deposit. And so the API becomes like, you know, a common denominator, מכנה משותף, that connects all the developers in the company. And if you do it well, you also built a little language for banking transactions, for financial transactions, for תנועות פיננסיות, right? So that's very important, I think. And if the class is mission critical, like this one, if it's very important to the organization, then once again, this is a very important thing to do. So that's one observation. The second observation is that we basically built the infrastructure, or tashdit, to do many other things. For example, suppose you want to write software that manages an ATM, or in Hebrew, kasfomat. I would argue that we already built a great deal of the necessary software. In particular, you will need logic that runs on the server, right? There will be a server somewhere in Amazon or in Microsoft, somewhere in the cloud, there will be a server that manages the bank accounts of all your customers. Now, it doesn't matter where they are located geographically, the bank accounts will be on this server. Now, we basically built the main class of this server, which is the bank account class. We know how to manage these accounts. Now, what else is needed in order to build an ATM system? Well, we also need a server-side database. And a database is a piece of software that enables you to take the data that you create in your programs and store them on the disk in a very well-structured and optimized way and secured way. Now, we're not going to talk about database management in this course. We have other courses in our university that talk about database management. But you have to understand that the infrastructure is there. We know how to create objects. And now what is missing is calling a database function that will take these objects and store them on the disk, which is relatively simple to do. So this is still missing. Another thing which is missing is the user interface. All the fancy buttons and menus and GUI graphical things that you want to put on the screen of the ATM or the screen of the telephone or the tablet or whatever in order to allow users to access their accounts and manage them. And finally, numerous operational details that we didn't talk about. We didn't check the validity of the data that we get. We didn't check if users go beyond their credit limit. We didn't check if users give you negative numbers when they should not give you negative numbers, and so on and so forth. All these things are done with a technique called exceptions that we will learn later on in the course. So there's lots of work to do in order to create an ATM system, and yet the most important infrastructure was already done in this class that you see here. And you may not appreciate it, but I wrote very little code, right? Every one of these methods takes 2-3 lines of code, and you have a system that can do a lot with little code. And this is a testimonial, or in Hebrew, edut. Testimonial is edut to the great utility, toilet of object-oriented programming. You can do a lot with relatively little code. All right, so that's what I wanted to say about bank accounts, and now let's move on to talk about fractions. Fractions, or in Hebrew, shvarim. And here is my fraction API. It's a class that represents a signed fraction, like half or minus 2/3. And it says that the fraction is characterized by a numerator and a denominator. Here's my constructor. If you give me two numbers, I can create a fraction from them. Here is a getter, or two getters for getting the numerator and denominator of the constructor. Of the fraction object. By the way, numerator is moneh and denominator is mechaneh. We have three fraction-oriented methods. I can add another fraction to the current fraction, to what is known as the this fraction, like the this bank account. I can multiply the current fraction by an other fraction. Once again, every word counts. I can invert, להפוך, the current version, or this fraction. I said version, I meant fraction. And I can print or return a textual representation of the current fraction, and the format will be numerator slash denominator. This is the API of fractions, and the beauty of this is that any programmer that wants to use fractions can now do it using this API. So let's do some client code, and let's focus on the constructor and the toString methods. And here's some relevant client code, which I gave you in a class that I called fraction demo. So we create two fractions, a and b. We print them, and we'll get this nice output. A equals 13, b equals 12. Then we create two more fractions, c and d, using some negative values, and we print them, and we get these printouts. And I look at this, and it doesn't look very good. -2 over -3. I would expect a clever class to modify it into 2 over 3. In other words, multiply both the numerator and denominator by -1 or something like this. Also, it's not customary to say 4 over -5. It is more customary to say -4 over 5. So these little things can be improved. When I print E, let's see, I constructed E with 8 and 16. When I print it, I get 8 over 16. Also, it could be improved, because if the constructor were clever, it would reduce the object. Or in Hebrew, היינו מצמצמים את השבר הזה. So, these constructors are kind of lazy. They simply create the fraction without trying to optimize it in any way. Obviously, later on, we'll make it better. All right, let's open up the code. We see that just like in bank account, we had ID, balance, and owner. Here, we have the two things which characterize, מאפיינים, fractions, שברים, numerator and denominator. So whenever I create a new fraction object, it will have these two pairs, or this pair of two values. The constructor is quite trivial. If you give two numbers, numerator and denominator, the constructor says this dot numerator equals the value of the numerator parameter, and this dot denominator equals the value of the denominator parameter. This is a special object variable that represents the current object, and when we say this numerator, we mean the numerator field of the current object, the object which in this case the constructor has just created. All right, moving along. toString promised to provide the numerator slash denominator. And that's exactly what it provides, right? It returns an expression that consists exactly of these values. And that's why when you print a fraction, you get this nice slash in the middle. This is thanks to the toString method. Moving along, here are the fields and the constructor that we saw before. And now I want to make it more clever. So we have a little problem here, right? When you want to be nice, you don't say a problem, you say issue. We have a little issue which has to be taken care of or ignored, whatever. So what should we do to reduce the fraction? Well, it's going to take a lot of work, so maybe we'll call some other method to do it, and that's exactly the way I do it. So here's a new version of my fraction, and now it says I'm going to construct a fraction. The newly constructed fraction is reduced, מצומצם. For example, given 8 and 16, I'm going to return 1/2. So I initialize my fields to numerator and denominator as usual, and then I call a method called reduce to perform the reduction. And notice that I apply reduce to the current object by saying this dot reduce. By the way, I don't have to do it. I can just say reduce, and Java will understand that I'm operating on the current object, but in this case I think it makes it a little bit more readable that we say this numerator equal this denominator equal this, and then this reduce it. All right. So call the method from this class on the current object, and let's take a look at reduce. How do you reduce a fraction? Well, it's not simple. You have to find the greatest common denominator of the numerator and the denominator and divide both of them by the GCD, by the greatest common denominator. For example, 8 and 16, you can divide them by 2, and then you get 4/8. But 2 is not the greatest common denominator, and neither is 4. The greatest common denominator in this case is 8, because you can divide both 8 and 16 by 8, and the result will be 1/2. This is what I mean by tzimtzum, reduction. So here's what I do. First, I check if the numerator is not 0. By the way, in a better design, the constructor would refuse to create a fraction that has a... I'm sorry, take it back. The numerator is the monet. The numerator can be 0, okay? So if the numerator is 0, it's already reduced. There's nothing to do. But if it's not 0, I'm going to call a method called Gcd, and Gcd will take the absolute value of the numerator, whatever it is, it will take the denominator, and it will compute and return the greatest common denominator. This is a number, whatever it is, I store it in the Gcd variable, which is a local variable in the reduce method, and then I divide the numerator and the denominator fields of the current object by Gcd. That's what this method is designed to do. All right, so we're still not in the promised land because we have to write the Gcd method, and that's what I do next. Notice that the fraction constructor calls reduce, and then the reduce method calls GCD, and I think I have an error in the slide because it does it in a slightly different way. You can look at the previous slide, but in any rate it calls the GCD method, and here's the GCD method itself. So the GCD method, which we haven't seen yet, is a helper function. It's a static function that takes two numbers, whatever they are, and computes and returns the greatest common denominator. There's a very famous algorithm, thanks to, I think, Archimedes for doing it, and this is the algorithm. You can verify at home that it actually works. And this algorithm returns the greatest common denominator of two numbers like 8 and 16, or 16 and 24, or whatever it is. And whatever is this GCD is, the function will return it, and other methods in the class can use it. Okay, so that's how I designed it, and as you see, reducing a fraction is a bit of work. It takes some work, but everything is very modular, and every method is no more than 4 or 5 lines of code, which is important. Now, in a better class design, I would have taken this GCD and put it in a different class. For example, if I have a class where I store all sorts of mathematical operations, it will make sense to put the GCD there. And then I will factor it out of this class into my math class. To factor something out means to reorganize it. You know, it's a fancy way of saying reorganize your code. And then your code will be better organized, you know, for 2 reasons. First of all, the GCD function has, you know, many different uses outside the fraction class. So it's nice that I can access it from my math class, which is where it belongs, a library of mathematical functions. And also by taking it out of the fraction class, I make the fraction class more compact and more focused and more focused on fractions. Okay, so it's a good thing to do to refactor this function to another class. All right, so here's the final version of my constructor. I added some API documentation. This is something that will be discussed in the recitations, in the tirgulim. If you read the documentation, you will see that this constructor does a lot of work. If the denominator, well, first of all, it reduces the fraction. If the denominator is negative, it will switch the signs of the numerator and the denominator, which is good. Once again, I provide some API documentation. And so I, first of all, handle the signs of the numerator and the denominator, and then I initialize the object fields, and then I reduce, and finally I will end up creating a good fraction. You know, whatever 2 numbers the user will throw at me, I will create a good-looking fraction and reduced fraction from it. There is one big issue which remains. If the user gives me a 0 denominator, I will happily create a fraction that has a 0 denominator, which is kind of crazy. And so this is something the constructor does not handle now, and it should handle it using the notion of exceptions, which we will learn later in the course. All right, so that's the class API of the fraction, and now what remains is to talk about the fraction-oriented operations like adding fractions, multiplying fractions, and so on. חיבור שברים, כפל שברים, וכדומה. So let's look at these 2 functions. Let's look at the client code. The client code can create 2 fractions, like 1/3 and 3/7, and then the client code can go on to compute the sum of these 2 fractions. And so I can say print A plus B equals A add B. I apply the add method to the A fraction, and I pass B as the other fraction. I can do the same with the multiplication, and by applying the multiply method, and I will get this very nicely looking output. 1/3 plus 3/7 equals whatever. 1/3 over 3 times 3/7 equals 1/7, or whatever it is. Okay. So once again, you know, just like I did with banking, I created a little language to work with the fractions, and this language is very convenient and the clients are going to love me because I just gave them the ability to create and manipulate fractions in their programs. Let's open up the code and look at multiply. Okay, returns the product of this fraction and the other fraction. Look at the data types. Notice that the type of the other parameter is fraction. It's an object. And the return value of multiply is also a fraction. Very important. A fraction times fraction returns a fraction. The code looks like this. Let's look at the parentheses. I'm taking the numerator of this fraction and I'm multiplying it times the numerator of the other fraction. And then I do the same with the denominator. When you multiply two fractions, you multiply on top, you multiply on bottom. Now, it's quite possible that the result will be something like 10 over 20. Okay? And I have to reduce it. The simplest way to reduce it is to take these numbers and ask the constructor to create a new fraction from it. And because the constructor reduces fractions, I'm going to get a reduced fraction as a result. And that's what I'm going to return. See, I was asked to multiply two fractions. I did it. And I'm returning the new fraction. If you read the code, it reads almost like poetry, right? You return a new fraction which consists of the product of the numerators and the product of the denominators. Perfect. So that's the code of multiplication. The code of addition is a little bit more complicated, just a little bit, and it looks like this. We multiply the numerator by the denominator of the other guy. We add the numerator of the other guy times our denominator, and we divide by the product of the two denominators. Once again, we take the result, we send it to the constructor will construct a new fractions from it, and that's what we return. So what you see here is what I consider a very, very elegant code for working with fractions. All right, let's take a look at the client code. We've seen already how the client code works with these methods. Here is one final example. I want to compute 1/3 over 3/7 plus 2/5. Notice that in Java I cannot do it because Java doesn't know how to represent 3/7 accurately. If I operate using the fraction class, I'm not losing any accuracy when I move from one operation to another, right? I keep everything very accurate. So I create these three fractions, and then I apply the multiply method to A, and as a parameter I give it the result of applying the add method on B, providing C as a parameter. This is the object-oriented way to say 1/3 times 3/7 plus 2/5. That's how I do it in the new language that the fraction class has created. And then I print, a nice printout, and I will get what we see here, 1/3 over blah 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 equals whatever it is. Okay. What else? Well, this is my class API, and I think that I have a few more methods that I haven't discussed. Invert and divide. We can talk about them quickly. Invert inverts the fraction, flips the numerator and the denominator, and divide divides the current fraction with the other fraction. Let's see how I define them. So the client code, if I want to compute 2/3 divided by 4/5, I just do it. I print a new fraction, which is 2/3 divided by some other fraction. That's one way of doing it without creating object variables. Let's look at the code, and the output will be whatever it is. Invert simply returns a new fraction in which we put the denominator on top and the numerator at bottom. So, mechane chelkei moneh. That's exactly the definition of an inverted function. Now, if I know how to invert, division becomes very simple. I can simply multiply this fraction, the current fraction, by the invert of the other fraction. If you think about it a little bit, this is elementary school algebra, and that's an elegant way to divide if I already know how to invert. And that's basically it. That's what I wanted to say about the fraction class, I think. This is the API, and notice that this API has no setters, no mutators, because it doesn't make sense to change a fraction, right? Think about it. If you created a fraction like 1/3, you don't want to change it into 2/5. You know, a fraction is a fraction is a fraction. If you want to add something to it or multiply something on it, that's a different story. But the fraction itself, no need to change it. And therefore, the fraction objects are immutable, and the simplest way to create an immutable object is to simply don't expose any setters. If you don't provide any setters to your clients, they cannot touch the object, they cannot change it. So that's important. Of course, I can create new fractions, but I cannot change existing ones. Now, we can use a class like this, fraction, for many useful applications. First of all, whenever you want to carry out accurate fraction computations, you can do it using this class. I personally have a lot of experience developing educational software, and what we have here is very good infrastructure for teaching children how to do fraction arithmetic. So I can write a program that generates random fractions and creates exercises for children, allow them to solve the exercises, compare them to the correct result, and so on. I have all the infrastructure ready in the form of this fraction class, and what is necessary is another class that will create a little game out of this. And in general, if there's an application that needs fractions, I now know how to support it. All right, so this has been this lecture in which we opened up two classes, bank account and fraction. We looked at how these black boxes actually work. And in the next lecture, we're going to continue to use the object-oriented technique to do all sorts of important things in computer science, like creating some very useful data structures that we will begin to illustrate in the next lecture. See you then.